The ocean isn't just water, it's an entire universe, vast, alien, and largely unexplored. More than 80% of the global ocean remains unmapped, unobserved, and unexplored, a staggering truth in the age of satellites and space telescopes. Beneath the surface, where sunlight fades into darkness, the rules of life change. Down here, it's not green forests and blue skies, it's crushing pressure, eternal night, and creatures that look like they were designed in a science fiction lab. And yet, this hidden kingdom is thriving, full of predators, survivors, and life forms that hold secrets we're only beginning to understand. The ocean is divided into distinct zones, each with its own unique residents and challenges. The first layer, the sunlit zone or epipelagic zone, extends about 200 meters down. Here, life is abundant. Coral reefs, schools of tuna, dolphins, and sea turtles. Sunlight fuels photosynthesis, which feeds plankton, which in turn sustains nearly every other creature in this layer. But as you descend past that 200-meter mark, the blue light dims, and you enter the twilight zone, a layer between 200 and 1,000 meters deep. Here, the sunlight is barely a memory. This is where life starts to adapt in strange ways. Big eyes to catch the last traces of light, bodies that glow with bioluminescence to attract prey or mates, and hunting strategies as bizarre as they are effective. Go deeper, past the point where light can reach it all, and you enter the midnight zone. 1,000 to 4,000 meters below the surface. Here, the pressure is more than 100 times greater than at sea level, temperatures hover near freezing, and life takes on forms so alien it's hard to believe they evolved on Earth. Some creatures here have no eyes at all, relying on vibrations and chemical signals to navigate. Others generate their own light in dazzling displays, nature's own neon signs advertising everything from danger to dinner. One of the most mind-bending examples is the anglerfish. This predator dangles a glowing lure in front of its mouth, tricking smaller fish into thinking they've found food, until it's too late. Some anglerfish species take things further. Males are tiny compared to females, and once they find a mate, they bite into her skin and literally fuse with her body, living as a permanent parasite, providing sperm whenever needed. It's brutal, it's strange, and it's effective. And then there's the vampire squid, a deep-sea drifter that looks like something from a gothic nightmare with webbed arms and bioluminescent spots. Despite its name, it doesn't suck blood. Instead, it survives on marine snow, the constant rain of organic material drifting down from the upper layers of the ocean. In the deep, where meals are rare, every scrap counts. Even deeper, at the bottom of the midnight zone, you reach the abyssal plain, vast flat regions covering more than half of the Earth's surface. It's here that the weirdness goes into overdrive. The gulper eel can swallow prey half its size thanks to its elastic jaws. The tripod fish plants its elongated fins into the seafloor and waits for food to drift past. And the giant tube worms of hydrothermal vents thrive without sunlight at all, instead relying on bacteria that convert chemicals from the vent water into energy. These hydrothermal vents are like underwater volcanoes, spewing mineral-rich water heated by magma beneath the seafloor. Discovered only in 1977, they completely rewrote our understanding of life. Here in complete darkness, in waters that can exceed 400 degrees Celsius, entire ecosystems flourish, proof that sunlight isn't the only way to power life. Tube worms can grow over 2 meters long, clams cluster in massive beds, and strange crabs with hairy claws nicknamed Yeti crabs farm bacteria on their own bodies for food. The deep ocean also has its own apex predators. The giant squid, once thought to be mythical, is very real, capable of reaching lengths over 12 meters. They battle sperm whales in epic deep-sea duels, leaving both scarred from their encounters. And then there's the blunt-nosed six-gill shark, an ancient species that's been around for over 200 million years, cruising the depths with a slow, deliberate grace. But for every species we've studied, there are countless more we haven't. Scientists estimate that there could be millions of undiscovered marine species living in the depths right now. In 2020, researchers using remotely operated vehicles in the Great Australian Bight discovered over 100 new species in a single expedition, including bizarre coral structures, glowing jellyfish, and fish with completely transparent heads. And here's where things get even more fascinating. These creatures aren't just curiosities. They hold secrets that could transform medicine, technology, and our understanding of life itself. Deep-sea bacteria are already being studied for their ability to survive extreme conditions, potentially leading to new antibiotics. The bioluminescent proteins found in jellyfish, have revolutionized medical imaging. Even the structure of shark skin has inspired antibacterial coatings for hospital equipment. Yet despite its importance, the deep ocean is under threat. Deep-sea mining, climate change, plastic pollution, and overfishing are pushing this fragile ecosystem to the brink before we've even fully explored it. Microplastics have been found in some of the deepest parts of the Mariana Trench. Warming oceans are altering currents, which can change where nutrients flow, and that ripples through the entire marine food chain. Exploring the deep is no easy feat. At extreme depths, pressure increases by about 1 atmosphere for every 10 meters you descend. By the time you reach the bottom of the Mariana Trench, the pressure is over 1,000 times that at the surface, enough to crush steel. Only a handful of manned submersibles have ever made the trip, including James Cameron's 2012 dive to nearly 11 kilometers down. Most exploration is done with remotely operated vehicles, equipped with robotic arms, high-definition cameras, and lights powerful enough to cut through the darkness. Still, every mission brings surprises. In 2016, a NOAA expedition captured footage of a ghostly white octopus, later nicknamed Casper, hovering over the seafloor at 4,290 meters deep. In 2021, scientists discovered a sponge and a coral living side by side in the depths, two species that shouldn't coexist, defying ecological expectations. And perhaps the biggest secret of all? The ocean may still hold the key to how life on Earth began. Many scientists believe that life's first spark could have ignited around hydrothermal vents billions of years ago, where heat, minerals, and chemistry created the conditions for the first living cells. If that's true, then studying these deep-sea ecosystems isn't just about exploring Earth. It's about understanding how life might arise on other worlds. The ocean is the Earth's beating heart. It regulates climate, produces over half the oxygen we breathe, and absorbs massive amounts of carbon dioxide. It's home to the largest animal ever to live, the blue whale, and to microscopic plankton that drift invisibly but keep the planet alive. Yet for all its importance, most of it remains a mystery. We're only beginning to peel back the curtain, and every expedition reminds us that we've barely scratched the surface. Somewhere down there, in the crushing dark, new species are evolving right now. Ecosystems are thriving in places we once thought impossible, and secrets, ancient, biological, and maybe even planetary, are waiting to be uncovered. The question is, will we protect it long enough to find them? The deep ocean is calling, and we've only just begun to listen. If you're fascinated by the strange, the unexplored, and the jaw-dropping realities of our planet's hidden worlds, make sure to follow us, because we're diving deeper into these mysteries every week, bringing you the stories the surface world never sees.